Hi, this is Sami Lemari, and I would like to demonstrate my task C and D for the AI module. So first, I would like to start with addressing the elephant in the room, which in this case is that I have been unable to find a even a weak connection as stated in the module specification for the datasets. I've been able to find one decent dataset, which is this dataset of 300,000 images of different galaxies. And although I have been very happy with the precision that this dataset gave me, and the pictures, they're awesome. They're exactly what I was looking for. Um, After doing all the testing and getting the data for the precision and uh, how correctly can the model predict, I have run into a major problem, which is that I do not really have anything to match the galaxies with. I was thinking about planets, constellations, supernovas, etc., etc. They were all very different to the point where even if the precision was very bad, um, the it would distinguish the pictures anyway. That's the first problem, and the second problem is that apart from this dataset seen on my screen right now, I couldn't find any other dataset for any other idea that I came up with. So I would pretty much have to either create a script to automatically download images of Google, which would then again have to be filtered out manually to see if actually those images are what I'm expecting and if for them to be in some degree similar, etc., etc. So that would be a very very lengthy road to undertake. So instead of that, I just scrapped it completely, and I went with the most basic, let's say, data set that's available, and that's dogs versus cats. Very similar animals, so that the model and its accuracy can be really benchmarked really well. Um, yeah. I hope this will not affect my grades in a negative way, because I have been searching, but I couldn't find a way to make it work with my current topic, which is space. So I hope that dogs and cats, or animals just in general, are a acceptable topic for the CND task. Anyway, let's get to my code. So this is my file for training the model. So some basic imports: CV2, NumPy, Pickle, Random, TQDM. Um, I'm using image size of 100 since that's the maximum image resolution, 100 by 100, that I could afford with my 16 gigabytes of RAM while training this, with roughly 30 to 35,000 images per category. So I found that 100 by 100 pixels would be actually as a kind of a sweet spot between not using too much resources and getting precise enough results. So that's why I went with that resolution. Um, yeah, besides that, nothing special. It's just a link to the dataset, the categories that are present in the dataset, and then just a for loop to loop through all the categories to, in this case, get all the images in. And yeah, I didn't really bother myself with really catching many errors, since there were none, so I just left it empty. And yeah, just some console logging here to see if the data is correct. Um, Yeah, and besides that, after the loop is done, all data should be in the arrays, and after that, it's really just using the pickle to make two files with the data, and after that, create a actual model from the trained data. So in my model create file, again, I'm using some imports, pickle time, some TensorFlow imports for sequential, some layering classes, etc. So basically, just reading in the import the pickles, declaring the density, the size, and the convolutional layers. Again, just looping through the categories. I mean, through the looping for each layer and density and convolutional layer, uh, and for the categories as well. And yeah, just adding up the layers here to the model with various attributes that I found helpful that raised the accuracy as I tested. And yeah, then it's just saving the model under one file, and once that's done, um, it can be loaded to the main script, to the actual chatbot. Let me see. Where did I? Oh yeah, so this is for task C. C and D, I should say. So this specifically is for task D. Just some Azure AI declarations for endpoints, training key, prediction resource ID, and assigning to some other stuff. This is specifically for task C, so pre-declaring the two categories, declaring the model, the name of the model, and yeah, just some prepare function to take in the image, process it, and get a result back. Beside that, there's just this command which will trigger when the user types in recognize and then the name of the file. So that's command 70, and once that's taken in, the image recognition will start. So first of all, there will be a so this is just to pre-prepare the image for convenience. So I have all my images stored here, and the code will append that JPEG because I had some issues with the dot in the command line triggering some protected commands. So I just added it as a string add-on via code. So it's only like dog underscore test underscore one. It also gets the directory and appends to it so that the image recognition gets the whole path of the image. Yeah, and pretty much the model predict gets the target, which is already appended with the whole directory and the file ending, and it will show the image so that the user knows exactly if the image it fed to the model is the one that he or she intended to. And yeah, beside that, it's just the result that gets displayed. And after that, the Azure API gets connected to, and the same the same the same file gets sent to the Azure AI, and the Azure AI also um, provides the user with its own estimate of what it thinks the image contains. Just a quick showcase. These are the images that I fed to there's 105 images of cats and 105 images of dogs. There's much less than what I fed to the local model just because of bandwidth restrictions and overall cloud storage restrictions that I encountered while using Azure AI, but it's really precise even when not using images that are contained. When using images that are not contained specifically in the dataset, so using random images and random images of dogs and cats, it's very precise nonetheless. And yeah, that's about it for explaining the code and Azure AI. So let's run this. There will be some TensorFlow errors. Yeah, we can already see them. These are mainly from what I understood, because although I do have a dedicated GPU on my device, I didn't go through the hassle of like declaring it manually for TensorFlow to use, just because it's too much of a hassle and it works really well even without it. So let's get started with the chatbot. Let's just greet it really quickly. Tell it how we're feeling, and let's get right to the business. So recognize. Let's start with cat. So cat test _1. So this is the image that we're trying to get the results for, and yeah, it shows us the target. So it's exactly here. Coursework part 2 cat test 1.jpg. Opening the reference image. Yeah, it opened in my image viewer, and the local model judged that this is a cat, which is correct, and Azure AI is 99.96% sure it's a cat as well, which is great. Let's do another one. Let's recognize dog test 1 this time. So this is the image of dog that we're looking to get the results for. And the local model judged that this is a dog, which is correct, and Azure AI is 98.8% sure this is a dog, which is correct as well. Let's just do 2 more quick tests to make sure that it has some it's rigid enough to to judge for 4 pictures at least in a row. So this was a cat, as we could have seen. The local model judged that it's a cat, and Azure AI is 99.99% sure it's a cat as well. Okay, that's great. And the last one, dog test 2. Let's see. So this is the image. The local model is pretty sure it's a dog, and yeah, Azure AI thinks 98.8% probability that that's a dog, and it's right, it was a dog. So yeah, the precision is really nice, just because these dogs versus cats datasets, they're so well prepared, and the data is, there's just so much data to go through to be prepared for really almost any type of image that gets fed to it, that it can really precisely judge as to what is a cat, what is a dog, because it has all this thousands and thousands and thousands of images of data to work with and learn from before getting into actually recognizing, which really is the main reason why I strayed away from my topic, which was space, so much. But yeah, I really do hope that the functionality gets judged much more than the topic. I didn't really, when choosing the topic, I didn't look this far into the future, as and didn't even think about will there be any datasets and even topics that I could put together in Task CND. So definitely lack of judgment on my side, but I really do hope that the functionality overlaps the topic selection for tasks CND. Thank you for listening, and I'll probably end the recording here. Thank you very much.